Hi, I'm Jonathan, and this is a video about my 8-bit computer. And in this video, I'll be showing you a prototype of the memory unit in my computer. So this prototype consists of two breadboards. This breadboard closest to the camera is the sort of I/O breadboard, so that contains inputs and outputs. And then this breadboard that's further away, that's all the logic in that one. So this prototype is only 4 bits instead of the 8 bits that the finished board will have when it's connected to my computer. As an overview, it has a dual port RAM, which is a regular RAM, except it can access 2 different addresses simultaneously. So I could be looking at address 1 on port 1, but I could be looking at address 53 on port 2. And it would just send out the values on the 2 different ports. And by the way, this dual port RAM has 256 bytes, and that will be acting as the registers in my computer. And then it also has a 32 kilobyte SRAM, so that's just your standard static RAM. It has 8-bit bus on that. And of course, all these chips are asynchronous, so no clock. And then this is a 4-bit buffer. The one in my final version will be an 8-bit buffer. But I have this so that I don't accidentally change the output of things before I can input them to the dual port RAM. Because if I have 2 outputs going from the dual port RAM into the ALU, and then after that the computer needs to write the output of those 2 values in whatever function to the dual port RAM again. If it does that without the buffer, when it goes to write it, it will be changing the address and disabling the output. And by doing that, it will cause the ALU to react to that and change the output, and that will ruin it. So I need the buffer to save the output, and then I can change the dual port RAM to an input mode without wrecking the output. So now I'll plug in my Arduino, which is just for power, and then I'll start up the circuit. So here I'm going to show you how I can send a value into the 4-bit buffer, then into the dual port RAM, then into the SRAM, and then send it out to another address on the dual port RAM, and then read them both at the same time. So right now, I have the outputs disabled on the dual port RAM, but if I enable them, you just kind of get this like garbage stuff, because it does that when it starts up. It has just undefined values. So first, what I'm going to do is I have the 4-bit input to the 4-bit buffer set as 5, which is 0, 0, 1, 0, 1 in binary. So this is the sort of thing that, represents the bus that's coming out of the ALU. So say I do some operation that results in 5, this is that's simulating that. So this goes to the 4-bit buffer chip, and then what I do to activate the write on that buffer is I send a write pulse, which I do by just setting this table here to high and then low again. And by doing that, I've written 5 to this buffer. And if I take this and set it to high, you can see that there's 5 there. And you might be thinking, why is the buffer output showing on the main output? And that's because the dual port RAM the interface is just I/O, so it's not input and output. So the output of the dual port RAM is connected to the output of the buffer also, but I never used that. So I have that going, and right now I have, for the write address of the buffer, I have it going to address 8. So I'm going to write 5 to address 8 in the dual port RAM. And to do this, I take the cable for writing on the dual port RAM, and I do the same sort of clock pulse thing. So I'll just set it to high and then to low. So now that value is written to address 8 in the dual port RAM. So now I'm going to disable the output of the buffer. So right now nothing has output, but as soon as I enable input on slot 1 of the dual port RAM, you can see that's outputting 5. So that's not coming from the buffer, that's coming from the dual port RAM. So for example, if I switch from address 8 to address 0, you'll see that you just get the garbage. But now that value is officially written to it, and that will be stable. So the next thing I'm going to do is I'm going to choose an address to write to the SRAM on, and that will be address 3. So I'm going to adjust that value. And again, the second address value for the dual port RAM, that goes to the SRAM also. So I wouldn't ever be trying to use the dual port RAM to read and the SRAM to write at the same time. So that doesn't really make a huge difference. So now I have address 3 going into the SRAM, and I have this value, which is 5, hooked up to the input values on the SRAM, which you can see are these 4 blue cables going into the SRAM. And what I'm going to do now is I'm going to enable the write. I think this one is right. I may be wrong, and I'll have to change that. But for right now, I'll try that. So I'm going to set this value to 1, and then back again. And by doing that, I should have written 5 to it unless I just triggered the read port, but I can redo that. So now I'm going to disable output on the dual port RAM, and then I'm going to take the input on the SRAM, or the output on the SRAM, and I'm going to set that to high. So I was right, this one is the output and this one is the input. And the reason why you can see it here, the output of the SRAM here, is the same reason you can see the output of the 4-bit buffer there. It's just connected to the bus because of the I/O. So now I have 5 written at address 8 in the dual port RAM, and I have 5 written at address 3 in the SRAM. So now what I'm going to do is I'm going to change the write address to 1, or I'll change it to 9 in the dual port RAM. So that's what it's going to write to. And since the output of the SRAM is connected to the write input of the dual port RAM, I can just write like that. So then I'm going to hook up, or I'm going to enable the write on the dual port RAM again, and this is writing to 9. So I'm going to do that little pulse. So now I've just written 5 from the SRAM to address 9 in the dual port RAM. So right now 5 is currently written to addresses 8 and 9 in the dual port RAM. So I can now go and disable the output on the SRAM. So now nothing has output. And now I'm going to switch the second address to address 8. So now on my left, or the camera's right, there's going to be address 9, which is 5, and then on the camera's left, there's going to be address 8, which is also going to be 5. So first what I'm going to do is I'm going to enable the first address, and you can see that's 5, and then I'm going to enable the second address, second output, and that's also 5. So that's a quick demo of my memory unit, and I can show you the fully fledged 8-bit memory unit once I've finished soldering that. Thanks for watching.